Okay, so here we see how we generate data with RStudio. We can do this in a few ways. We can generate regular sequences with a colon symbol. So for 10 elements, we assign to the object x. There's the arrows pointing towards x. This is a less than minus, and 1:10. And then if we want to show this, we type x, and we see we have the numbers 1 through 10. Now, what if we wanted to take those numbers and say multiply them by 2, or subtract 3 to all of them, or square them, or divide them by 3? We could do this as the operation can be done on a sequence created with colon. So here we have the even numbers to 20. So colon. Next, seq for sequence. So we can generate sequences. Now we can have a little more control. What is the increment we want to use? So for instance, if we want the evens from 0 to 10 by 2, of course, then we write sequence 0 from 0 to 10, and by how much? By 2. We can also choose how long we'd like a sequence to be, and we can say from what to what. In this case, we have from 0.1 to 1.0, and we want a length of 10 entries, so exactly how long this is. So this is for SEQ. Now we can also just type things in directly using C. So C parentheses, and we separate by commas all our entries, and here we have those numbers done, the sequence created. We can also enter data from the keyboard with scan. So let me show how we would do this using RStudio directly. And so here I am in RStudio, and I would like to use scan. So I'm going to scan. I'm going to say x, assign to x whatever has been scanned, and then scan enter gives me well, what do you want first? Well, how about 2? What do you want next? 1. What do you want after? 4. What do you want after is 5. And what do you want last? 7. And then I press enter one more time, and it tells me you've had 5 items. Let's see what's in there. What's in 5 is 2, 1, 4, 5, 7, exactly as I typed it. Now, I could do it again. I could do the scan again. Just reuse x. And I could just say 2, 3, 4, 5, 6, 1, 9, 10. Just separating this on one line. Press enter, and tells me it read 8 items. Notice I don't have to just press enter each time. And so, for instance, this is helpful if I copied a list of numbers directly from a page, say somewhere on the internet, and I wanted to just paste it directly onto here RStudio, and scan would work quite well for doing this. Now, so if I wanted to pull information from, say, a file like this, so let me just show this. I'm told that 29 students were set a simple task, and we have the times completed for this task. This is in some PowerPoint presentation. I'm just going to highlight all the colors, all the numbers, copy them, and go right back to RStudio. And here I'm going to say x is scan, enter. I'm going to just paste all of this. I don't have to type anything. Enter one more time, enter again, and then what's in this? In x I have precisely what I wanted, so I could just do a quick box plot of x, for instance, and there we would have it. Nice, so we could do a stem and leaf plot of x as well, and this would look like this. And of course we could do a summary of our data, and there it is. So continuing, we can also create sequences in rep if you want repetition of the same value. For instance, if I want 8 copies of 3, rep 3, 8. That's for creating regular sequences in a variety of ways. What more can we do? we can have series of factors. So GL is for general levels, K is for the number of levels, N is for the number of replicates. So if we do GL2 5, we're saying we have 2 levels and we want them 5 times each. And so notice when we do this, we have 5 ones and 5 twos. That can be helpful for us when we're creating random data. So we can also change the labels. If we want heads and tail, H and T for heads and tail for flipping coin, C and T for control and treatment if we're interested in randomize and assignment to groups. And so that's for series of factors. Now how about random sequences? Those are all regular sequences of series of factors. Now how about random sequences? If we'd like to flip a coin, we can do this. We can do this in a few ways, but we could start with R binom. Yeah, R binom takes in N is for the number of times we want to do the same experiment, and X is for, well, we're putting into the object X what R binom is going to give out, meaning it's going to tell us that if we do 100 times the experiment with one repeat of each experiment where the probability is 0.5, it's actually flipping a fair coin. Let's do this. And so notice if we look at what's in X, we see the first few values using head, and so 0 which says head, and 1 is tail. So this is head, tail, head, 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 head. If we want to encode things using zeros and ones, we could tabulate things using table. Notice we got 46 head and 54 tail in this case. Okay, close to what we'd expect. Of course, the law of large numbers gives that the proportions would be close to 0.5 if n was really large. Continuing. How about flipping a coin and getting more information out of this? So let's just create a coin. Okay, but let's use sample this time. So we'll say n is 100. We'll say a coin is, well, has a tail, the two options here. And we're going to simulate sim 100 by sampling. So it means we're going to take from the coin either head of tail, and we're going to replace every time. So just flip your coin multiple times. How many times? N times 100 times. And so if we look at the head there, we see head, tail, head, 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 tail, and so on and so forth. There's 100 of those, so I'm not showing all of them here. And so what if we want to find, for instance, if we're interested in streaks? If we want to ask questions of hot hand, for instance, or streaks. And so how about the runs of heads and tail? So we could use RLE for this. Yeah, run length encoding for this, and it gives us the length and the values, right? So head, notice the first entry is head, and then we have one tail, with one head, one tail, and we have 3 heads, right? So you should say 113, and it does exactly that. Okay, and so on and so forth. So that's for random sequences in terms of flipping a coin. And this could be visualized in many ways if we wanted to do so. And so if we continue, can we generate random sequences from a Gaussian distribution, a normal distribution? We do this with R norm. Notice we use R binom. The R is for random, and norm is the normal distribution. So it's the name distribution. So 100 of those from the random normal, from the normal distribution. So this random deviates from the normal distribution. The default here is that the mean is 0 and the standard deviation is 1. We could change that if we wanted to, but in the example here I'm just sticking to 0 and 1. So create a box plot, and does it look pretty normal, as in does it look symmetric? Well, it sure does look fairly symmetric here. Box plot is nice, the median looks pretty much in the middle. This is good. Okay. A histogram would be helpful to look at here, and we could use the hist command for this. So let's have a quick look at that using RStudio. So if I want to create my deviates, I'll do this, and I say, well, I want 100, right? So let's say n equals 100, and let's say I wanted my X to be my R norm N, and then if on my histogram I could do the histogram of R norm of X rather. And so this is what it looks like there on the side. Does it look pretty normal? Well, it's going to look normal if we really replicate these deviates in much larger numbers. So let's do it again, but this time let's do n equals 1,000, and then I'm going to do this again, and then the histogram again. Notice it's starting to look much nicer in terms of a normal distribution. So the larger the value, the more normal it's going to be. Okay, now continuing, we could generate pairs, right, with R norm, and this time we have points in the plane. X are created, the Y's are created, and they're plotted here in 2 dimension, and this can also be done for us in pretty much the same way as we did for the X, and we'll do that for the Y, and we'll plot X and Y on a grid here. And this is what we want to show here in terms of generating sequences. So we can generate regular sequences. We can, in a variety of ways, we can generate factor series of factors, and we can also generate random sequences.